Thanks for joining me for Implications of Flutter WASM, or WebAssembly. My name is Kyle Finlinson, and preparing this talk has been really inspiring to me to see so many exciting things that people are doing in Flutter and beyond. Quick introduction for myself. I worked at Google for about 6 years, helping the Gmail and Google Voice teams to ship faster and safer. And the last few years I've been working with Very Good Ventures, and it's been really great working with Flutter. And if you want to find me after this, LinkedIn is the best place to connect. Overview of things I want to cover here. So we'll do some background, then talk about what is WebAssembly and the status of other WebAssembly. We'll talk about the other languages in WebAssembly, and then some Flutter specifics. And then in the Flutter ecosystem, what should we do about it? And then some things that I think are exciting that are coming up. So to start with some background, earlier this year it was announced that Flutter WebAssembly support is stable. So what? And to answer that, I'd like to rephrase the question a little bit to say, so what? Some of you may recognize these from a pretty iconic talk, one of my favorites, lightning talk by Gary Bernhardt, where he talked about kind of just poking fun at a few different programming languages, but specifically JavaScript, and just gave some examples of just really strange, unexpected behaviors, like these where you're adding empty arrays or empty objects together in different orders, and they all will give you different results, and none of them make sense. So this talk has probably influenced my career more than it should have, but it's worth a watch. The same year as that talk, which was toward the beginning of my career, the Dart team was just starting out. This was well before Flutter, but TypeScript also started to, JavaScript is kind of a weird language, and they were trying to fix some of the quirks, particularly by adding a type system that enforces how you write your code to make things, especially in bigger production code bases, easier to reason about, easier to not write bugs. So in this article, the Dart team said, what does this mean for Dart? We're more excited than ever. And the Dart team decided, we're gonna break from JavaScript. There are some things that JavaScript allows you to do that just cause problems. And Dart is just not gonna allow you to do those things. And TypeScript took a different approach so Dart, you can compile all your code into JavaScript, but TypeScript is fully compatible with JavaScript, and it just adds types on top of it. So, it's just different trade-offs. I like the comparison that people have said, TypeScript's approach is kind of like putting lipstick on a pig, but underneath it's still a pig. There's still JavaScript under everything. As I say this, I in no way want to minimize or belittle any the excellent engineering that has been done in the JavaScript ecosystem. There are some really impressive projects that are incredible. But JavaScript has some quirks, and so then this is the definition of WebAssembly from the and this is an excellent resource. So they said, historically, the virtual machine has been able to load only a web browser, so you can only use JavaScript. This has worked well for us as JavaScript is powerful enough to solve most problems people have on the web today, but we have run into performance problems with JavaScript, especially for intensive use cases like 3D games, VR and AR, computer vision, image and video editing, and other things that you need native performance. Google Sheets this is a really great recent podcast. They talked about using using WebAssembly to speed up Google Sheets. And they asked why even make garbage collected languages compile into WebAssembly? We'll get more into that later, but the answer is performance. The calculation engine that determines what is in each cell of your spreadsheet and all the calculates all your formulas and everything, that has always been written in Java code. And then they transpile it into JavaScript. And having from my time on these Google teams, like they have some really incredible infrastructure and really interesting things to share code across platforms. But we've spent a decade optimizing the JavaScript performance, and it hit a ceiling a long time ago. They've known for at least a decade that JavaScript executes the calculation engine 3 times slower than, so it's much slower than the JVM. We know that there's a huge amount of headroom there, but there's no way to capture it because JavaScript is holding us back. So enter WebAssembly. So for the history of the web, to write a website, you have HTML to describe like the text, the content, the basic structure of what's on your page. CSS provides styling, spacing, colors, animations, and JavaScript for interactivity and more dynamic behaviors. And in 2019, WebAssembly became the 4th official language for the web. And it's an official web standard, which means it'll be supported by all the major browsers. And it's safe, portable, it's a low-level format to have efficient, like more higher performance in a web browser. So previously, like you write code in whatever programming language you want, whatever makes sense for your use case, and then you have to compile it into a binary executable file. So then and then your users have to go download this code, so they have to install it on their computer. So you need an exe for Windows, or for Mac, you have to know like what is it, an x84 or 64 or x86 architecture, and download the right binary. But with WebAssembly, you can just compile your code to one WebAssembly binary, and it can run across any operating system, any platform, and your users don't have to download and install it. And that is handled by the browsers. You can also run it not in a browser, and there are tons of super interesting use cases that I wasn't aware of until recently, where people are using WebAssembly outside of the browser. So these, like WASMer and WASM time are 2 of the biggest, but there are a lot of different WASM run times depending on what you're trying to do. So this is basically, it can be like an interpreter or a compiler that it either just like executes your WASM code directly, or it can compile it into one of these native binaries. So WebAssembly is just this really powerful standard that whatever programming language you want to use can be compiled into WebAssembly and then used anywhere. This diagram is mostly from Cyrus Akbari's blog post, the CEO of WASMer, and also this awesome WASM runtimes has just a list of a bunch of different options that you might want to look into. So outside of the browser, WASI is another really important area that it's a group of standard APIs, and this is another also being developed as a standard. So this gives you, it's designed to have a secure standard interface that applications can be compiled to WASM from any language, run anywhere, browsers, in the cloud, and embedded devices. And by standardizing these APIs, WASI gives us a way to compose software that's written in different languages without the overhead of HTTP microservices. Some examples of these APIs is like input and output, clocks, file system, sockets, and so WASI is just a standard interface that can be implemented on any platform. So then if your WebAssembly code is also using these WASI APIs, then you don't have to implement or know all the details of all the different platforms and operating systems that might be running your code. There were a lot of really great talks that I've been watching from WASM.io a few months ago. And this one, he talked about that WebAssembly gives a lot of the similar benefits that we get from Docker containers and Kubernetes, but it's actually better in a lot of ways. That WebAssembly binaries are smaller, they're more cross-platform and cross-language than containers are, the sandboxing for security is safer, that WebAssembly modules are only allowed to access memory that is explicitly granted to them, or resources that they're explicitly given access to. And they have faster startup times, which is really important, especially for like those cloud functions where sometimes like you might need to run cloud function, like have just like most of the time it's not doing anything, but it has to be ready just in case somebody sends a request. And so you're just wasting a lot of resources just running this server that doesn't need to do anything. But WebAssembly, the startup time is so fast, you don't need the server to be running all the time. Just when you get a request, you can immediately start running the WebAssembly. So similar benefits that we get from containers. One of the co-founders of Docker said a few years ago that if WASM and WASI existed in 2008, we wouldn't have needed to create Docker, which to me was pretty profound. That's how important it is. WebAssembly on the server is the future of computing. And then going back to that same talk, so it's faster, more secure containers. That sounds great, like those are good benefits, but there's more. And that comes from the component model. So Luke Wagner is he's leading some of these standards for WASI and WASM. So the component model, basically, he described it as a mix of like source language modules where you could like import different libraries that are written in your programming language. But it's also kind of like microservices that could be written in any language, and then you send like RPC commands to communicate across processes. And components is, you get the benefits of both of those. So here's an example from same speaker, different talk. So currently, if you want to reuse code, you have to choose which programming language you're going to use, and then you can basically only use the code that has been written in that language. So you have to choose a language, then you can mix all your dependencies together. But they also all have access to the same memory, the same resources. So if one of those is having problems or misbehaving, it can corrupt your whole program. With WebAssembly, it's language neutral, and each module or component is sandboxed. So it is only allowed to access the memory and the resources that it's been given, and you can mix and match code from multiple languages, which is just a lot safer and more flexible. Another example, I mean, there's people doing lots of really interesting things. Zig is a new programming language similar to Rust, but they originally had to implement their compiler in C++ and in Zig. And they have some videos and articles about why. And with using WebAssembly, they were able to delete their C++ implementation. So they don't have to implement every feature twice anymore. It's just all Zig.
I don't know, man.
This one? There we go.
This one. Sorry. This one. Yours is not working for whatever reason. Thank you.
Okay. I thought this was a great quote from a closing talk, that WebAssembly connects past and the future. So this was a great talk, kind of covering the history of like virtualization of like architectures and memory, and kind of how we evolved from virtual machines and containers. And this was a great talk. And I thought another interesting reason that WebAssembly is pretty fascinating. And so when I started writing this talk, I knew it was interesting to me for Flutter, but it's interesting for front-end web development because it enables you to have better performance in your web apps than you could have before. But it's also interesting for like native front-end developers, like on mobile or on desktop, that now we have ways to distribute your software without going through the App Store, that you can just send somebody a URL and they can use your app without having to install anything. You can have the phrase that always comes up is near native performance, which is like very near native. It's interesting for back-end developers because they can mix and match languages and work across platforms and operating systems. It's great for back-end operations that like you have the flexibility to manage your back-end infrastructure however you need to, and potentially be faster and safer than containers. In embedded systems, you have the flexibility to run across operating systems, and like especially for new languages, you don't have to build the whole tool chain and the whole ecosystem. You could share and like reuse code from other languages that do what you need. And if you're managing the full stack, then like again, being able to choose what languages you want and handle all of these things. So lots of different languages are working to support WebAssembly right now. So a few that I thought were interesting. The ones that have the best support currently are these that you manually manage memory. So Rust is the best supported, and C and C++ have excellent support. And I think these are using the original WebAssembly spec that was approved in 2019. And like these are in production in all major browsers, and they've enabled projects like Figma and Photoshop and like Unreal Engine games or Google Earth to be able to like use their C++ rendering that's like really intense graphical computations, and that's all happening in these low-level languages now instead of JavaScript, where you probably wouldn't have been able to do those types of experiences in JavaScript. I think Swift is an interesting one because it uses automatic reference counting, so you can use a nice modern language, but you don't have to like manually manage all of the memory allocation like you would with C++. And if you're interested in Swift, you should definitely check out Tokamak UI, which it generates from your Swift code like HTML and CSS from your Swift UI components, which I think is an interesting project. On the other side, there are garbage collected languages where you don't have to manage the memory manually. This was just this year has been rolling out in browsers. So the support in Chrome is good. We'll talk more about that later. But this enables more languages like Go. A couple notes about these. Go uses garbage collection by default, but I've heard like people you can use different garbage collectors depending on what you need. Or you can run it without a garbage collector. You can like manage the memory manually if you want to. But for Go, you can't currently, you can't just use regular Go. Not all of the language features are supported in WebAssembly. So there's a project called TinyGo. TinyGo like strips out the parts. It's just like a minimal subset of Go that works with WebAssembly. And I think with Kotlin and Java to me are interesting. Kotlin has a lot of things going on with like Kotlin multi-platform and Jetpack Compose. So they have rich UI libraries, and Java has a giant server ecosystem. So that seems like that could be compelling. With Kotlin, I saw that you can compile your code to JavaScript or to WebAssembly. But a little spoiler, with Flutter, it does that automatically, which is nice. So probably not a huge amount of work to set it up yourself, but you get it for free with Flutter. C# and .NET have their roadmap is really strong. Seems like their support is coming along really well. I also thought it was interesting that you can compile JavaScript into WebAssembly, which seems kind of circular, but I think people are getting better performance and there's just like all kinds of weird projects and interesting ways people are playing with these things to do lots of different things. So if you want to learn more about programming languages and their current support, Fermyon is like a collection of open source tools, and they have this language matrix. So you can see like what's the current level of support. And this is open source. I actually just submitted a pull request to update the Dart status a few days ago, and they approved it really quickly. So this is a good starting place if you want to learn about your favorite language, and all of these open to sub pages with more references. So what specific to Flutter? Like I mentioned, the JavaScript, that I think this is a really helpful thing that other languages probably could do this. Some of them, I don't know that they really support being compiled to JavaScript very well, and you would need to like manage it yourself. But with Flutter, like if you build your app for WebAssembly, it automatically builds it for JavaScript as well, and then when you run your app, it will detect like, can we use WebAssembly? And we do if we can, and if it doesn't, it automatically falls back to JavaScript. So you can be confident that your app's just not going to break when somebody tries to use it, and it's like, well, we can't run that. Tree shaking seems like a big advantage, where like Flutter and Dart have been designed to work cross-platform, and like tree shaking, it like strips out the code that you're not using in your app to make your binary smaller, and just like these types of things where like other languages maybe weren't designed to send binaries to a web browser, so they may have like huge standard libraries that you don't need the whole thing, and it doesn't make sense to make people download it every time. So that is nice that Flutter only uses the parts that you need. I think cross-platform debugging could also be really helpful, because WebAssembly, a big criticism and concern is debuggability, to be able to like understand stepping through what's happening in the code. And there are ways that you can like include the debug symbols and symbolic links and things when you compile your app, and I'll mention those again later. But also with Flutter, like I think it was mentioned earlier today that it might not be the ideal solution, but you can often run your app on a different platform. So if you're hitting a weird bug on web and it's hard to reproduce, maybe you can compile it to run as a Mac app or as an iOS app, and maybe depending on what type of bug it is, you might be able to debug on a completely different platform. A downside is there's currently not WASI support, so like the whole server side of things isn't really supported for Dart right now, but there is a ticket we can upvote. A few demos to talk about. So I mean, this is definitely a big asterisk, but Craig Leben's mentioned at like Flutter IO that some of the demos he's seen for performance, they've seen like 300 to 500 frames per second for the calculations. I mean, those are, I think, probably like pretty simple examples, but like it seems promising that the performance could be really improved compared to JavaScript. So Wondrous is a great example, which was not designed to run on the web. Of course, Hanon has some great examples with shaders and Flame games. And I also came across this Nick Fisher's website that he has some cool stuff and write-up of what he used. To be able to tell so like when you're playing with these examples, you can right-click on the web page and then inspect the element, and in the network tab you can see, like, is it using the JavaScript files or WASM files? And I thought this was a good take when they announced that Flutter WebAssembly was stable. So there's two ways to read the news. One, it's an exciting feature for Flutter Web. It's also an exciting feature for the web, to have a robust UI framework like Flutter coming to WebAssembly. And I agree with that. I think, to me, both are interesting and both are exciting. So now, what do we do about it as Flutter developers? So the first thing is browsers need to support it, and then your dependencies need to support it, and then your code needs to support it. So we'll talk through each of those. With browsers, I mean, I definitely encourage you to do your own homework depending on like the market and specific problems that you're interested in your user base. But I looked at a few different examples, and the data is this is kind of the current landscape of things. That there are some differences, like if you look at desktop versus mobile, or the US or Europe or Asia, or like different regions of the world, the breakdown's a little bit different. But basically, Chrome is about 65% of the market. Safari is a big chunk. Edge, Microsoft, and Firefox are good, are also like a pretty significant percentage. On mobile, Samsung is in third place instead of Edge. And then also, I thought it was interesting to see which browsers are based on Chromium. So a lot of these others browsers include like Brave or I've really been liking the Arc browser recently, and it's also based on Chromium. So anyone who's using a recent version of any of these browsers they have WebAssembly like WASM GC support that works with Flutter. So Chrome, Edge, Opera, most of these are covered. The two big ones that are left are Safari and Firefox. So with Safari, actually just a few weeks ago, they just announced that by default, WebAssembly support is turned on for WASM GC. From the Flutter docs, they link to these, they say to like upvote these issues if you want. So you can add yourself to the CC list. But since I started watching this a few months ago, there were like 7 or 8 issues that were open, and they've closed a few just in the last few months. So they're making progress on it. And then there's also a Flutter issue now now they can start working on the Flutter side to get Flutter to work with it. And I think they're gonna keep finding bugs there, but seems like good progress is being made, and oh, I forgot his name. Sorry. One of the leaders from the Dart team said that he's hopeful, he's optimistic that Kevin Moore said he's optimistic that they'll have support in all the major browsers by the end of this year. Eric Seidel said it's been a long road, and he thinks it's still going to be a long road. I think they might both be right. It looks like hopefully we'll have stable support for kind of the basics by the end of the year, but there's a lot of exciting things that people are going to continue working on for a long time. Also note that Safari uses WebKit, and on iOS, every browser is required to use WebKit. So until this is working, no iOS browser will work with this. But once this is available, then Chrome or Firefox on iOS should also be able to work. For Firefox, they have support, but they have this bug where the off-screen canvas is really slow. And that's part of how WebAssembly, how Flutter is able to have such good performance, because it does like off-screen rendering on an off-screen canvas to kind of pre-compute a lot of things, and then like, it shares things across threads, and that's really slow on Firefox. So I wanted to show you these screenshots because it took me a while to dig into how to vote for this. So you have to expand the details tab, and then click the vote button, and then check the box, and then click change my vote. So just wanted to show that if you want to go in there and say I did my part. So once the browsers support it, then we need all of our dependencies to support WebAssembly. So it's really easy to check. You can just search for is WASM ready? And basically all that means is they don't use these old packages. So tons of packages are supported just because they're not using those. Any state management library, block or riverpod or whatever, like lots of packages are supported. And to me it seems, depending on what your package is and how you're using the old libraries, will affect a lot how much effort it is to migrate. I think some of them, it'll be pretty trivial. For others, like there was one mentioned today, a browser package that kind of wraps the whole Chrome API. I think that is going to take a while. But there are some more other libraries that are included in these that you shouldn't use anymore. But these two new ones are recommended. Two things to note. So instead of Dart HTML, now it's package web. So by being a package, that means it's decoupled from the Dart SDK. So as things are always evolving on the web, now we don't have to wait for a new Dart release to be able to get a new version. Like they can just release package updates. And you could also like overwrite this with your own custom package if you wanted to for any reason. And then also don't use the package JS interop because it doesn't do what you want, and it also has a non-permissive open source license. So thanks to Hinan for that in his talk a week or two ago at Flutter and Friends. I definitely recommend you check out his talk because he went into some really interesting details of like what gets compiled in WASM mode for Flutter versus in regular web builds. So this is how so after your dependencies and all your code are not using the old libraries, they've all been updated, then you just do flutter run WASM, and that's pretty much it. So that works in stable. On the beta channel, you can, or build works in stable, run has to be on beta currently, but these are also flags you can include to help with debugging. And like I mentioned, it also builds JavaScript and will automatically fall back if the browser doesn't support it. And then when you're serving on your server, you also need to include these two flags because it does that, like multiple threads for the off-screen rendering. You need to not allow like cross-origin policies. So now, what do we build with it now that we have these things? So near-native performance is great for things like mining cryptocurrency, or the metaverse, or AI, or whatever the utopia of the year is. It will probably need more compute. And some other examples, like there was a good list on the webassembly.dev website, or webassembly.org. And they talk about like spreadsheets or like image and photo editing, music, streaming, VR and AR, like anything that you have really intense graphics and computation. It's not, like Flutter Web is not really great for documentation sites. If you just have like maybe blogs, depending on what you want to include in your blog, like if the navigation and the content is pretty linear, it's mostly text and links. If you have a site, they talk about sites versus apps. So they have different benefits and drawbacks. So if you really need like fast initial load times, SEO and indexability, and accessibility, and resilience, that like the web page will be able to show something even if JavaScript isn't available, then you should probably just use HTML and CSS. Apps, like if you have like more intense computation and user state, and I think these are kind of, it's kind of juxtaposed, or like if your app has a lot of user state, like what's in your shopping cart and what are your documents that you've written and saved, like you probably don't want all of those things exposed on a search engine. So like, is it a highly interactive experience and like with really complex animations and transitions between pages or different parts of your app? But this is also kind of a spectrum. Like some sites, like shopping is a good example, where you might have a shopping app that like you want the things that you're selling to have good SEO for people to be able to search and find them, but like interacting with the shopping cart and things is a pretty app-like behavior. So I really recommend this talk from Rich Harris that created Svelte in the JavaScript ecosystem. He talked about transitional apps, which is basically just kind of embracing the strengths of traditional approaches and like classic approaches with the benefits of more modern approaches. So some ideas about that. This is a really great article recently about how to optimize your Flutter web apps. Would recommend looking into these, of how you can have a landing page, like lazily loading only the imports that you're actually using when you need them, preloading assets, and like caching, not doing long asynchronous operations at load time. And this article digs into all of these. I definitely recommend. And one part that I really thought was interesting, that browsers cache your WebAssembly files, like the CanvasKit renderer. And so this means that the cached WebAssembly can load as quickly as native binaries, where JavaScript, even if you already have it cached, it still needs to reparse and recompile and like rejit the code. So the first time you load a WebAssembly app page, it will be slower, but after that, then it has the native code available. I would also recommend looking into Jasper. It's a framework from Killian that I think is really interesting, that you write all of it in Dart code, but then, so it feels really familiar to Flutter, but then it compiles it into just HTML and CSS. So you get all those benefits of like SEO and indexability and initial load times, but you can write it in Dart. So this is an example of like your app uses stateless components instead of stateless widgets, but when you return, like you're returning divs and h1 tags and paragraphs and text. So like these are all HTML elements, and the like CSS is similar to that. Like you can use like Tailwind or like whatever CSS libraries you want to use with Jasper. So then you can share your Dart code and you can share your state management across like your website and your Flutter apps across platforms and your server. So you can share a lot of code. And this I think is really interesting, that you can just embed a Flutter app directly. So you can do that with any web page, and like the flutter.dev has some good documentation about how to do that. But there are a few pieces to hook up, where with Jasper it's just a component and you just put it in there and you can have like an entire Flutter app as part of your web page. A couple things that I think are exciting coming up. I thought this was a good read. Hixie wrote an article, Ian Hickson, called Towards a Modern Web Stack. He talked about some of the like lower level APIs that could be exposed to WebAssembly so that it doesn't have to go through JavaScript to access like all the browser APIs, and like to be able to interface directly with like web GPU, and to have better accessibility within like single page apps. So that was interesting, kind of an aspirational document. It's also mentioned today that Impeller has been designed so that eventually it will be compatible with web GPU. So it's not there yet, but someday our web apps will work with that, and so then we can have the like much better performance without having to change our code as Flutter developers. And then also, adding support for the non-JavaScript WASM runtimes so that we can use Dart for those interesting server applications outside the browser. So I wanted to close with this, that back to Google Sheets, they said, we've learned from all this. I mean, they were started with JavaScript, Java, and then just rewriting things in multiple times and compiling things in different directions. So Michael Thomas said, if you get your code written in a good language that can be deployed in multiple locations well, now you can support any application architecture. Any code you have can run on the server if that makes sense in some situations. It can run on the client if that's better in other situations. They're fully flexible footing to run any code in any way on any device depending upon what's best, which I think is valuable for a lot of cases, but especially for AI. Like you can run the same models, the same code. If you want it to be on device, if you want it to be on the server, you can share your code wherever. And then you get yourself in this flexible situation. And no matter what comes down the pipe, if there's a new device, a new form factor, a new architecture, and you're positioned to do well. So I really liked this thought from Slava on the Dart team. That if you like Dart and Flutter, the best thing you can do is to build new things with them. So with that, let's go build awesome things together. Thank you. Do we have time for questions? Or probably people want to go party?
I know you talked about it a bit in the Dart case, but do you see any use cases for Flutter WASM in the non-browser runtimes that you were describing?
With Flutter specifically, probably for embedded devices, that might be interesting. Yeah, because then, but I mean, Flutter already has support across so many platforms that you could just compile it to native code. So I would think probably embedded would be the best chance, but even there, like you can write, there are custom embedders. So I think it could be interesting, yeah, for embedded cases where you don't want to write a Flutter embedder, like you could maybe just compile it all to WebAssembly. It seems like it would probably be a long time before that type of situation would support everything you would need to run a Flutter app though. So to me, it seems more interesting, more for the Dart case than for Flutter to like be able to run Dart code on your server. Like, I'm like Tom and Stefan's talk tomorrow, they're going to be talking about like AWS and Dart Frog on the server, that you could run that type of code without having to deploy containers, and like you could use WebAssembly modules for that.
So I get that for as far as accessibility goes, like HTML is a better option for that. That's what you need. I'm just wondering, is there any roadmap for things like screen readers or anything to work better on WASM?
Yeah, they were just talking about that this morning. The Dart leadership panel. They talked about that. How was it? So I think you currently can have support, but you have to go into your browser settings and turn on accessibility. But that is a pretty big performance cost. So it sounds like they have some promising experiments that they'll be able to solve the performance issues and then have it on by default. And also Hixie talked about that in his, where like to be able to use the ARIA APIs to like basically use the accessibility tree to describe what's on the screen instead of relying on the HTML. Any other questions? Okay, thank you very much.